在这个过程中主要是会说技术，然后呢基本上全程是会用英文去进行讲解，所以这样的话就是跟大家提前先说一下。如果再等个几分钟差不多，那我就可以开始做今天这个演讲了。如果大家有问题，可以通过这个 question 这个 section 跟我提。如果在讲的过程中跟这个有关系的，我肯定会停下来，然后重复一遍，然后跟大家解释一下这个问题啊，哪里有不清楚，或者是哪里有一些疑惑所在。主要我倒是希望大家能够多互动一下，然后在这个里面相当于更加多的交流一下这些大数据分析相方面的经验吧。然后趁这个时间也介绍一下我的公司，我的公司叫 Taste Analytics。这个公司呢，我们现在是在东部做 To B 的这个企业级数据分析，Predictive Analytics 和 Visual Analytics 图像分析的这块的这个产品和平台。我们现在的一些客户都是一些 Fortune 500的一些客户在这里面，然后我们也是在一个非常快速的kind of growth period。如果有感兴趣的朋友啊什么的，也可以在私下里面加我的微信或者加我 LinkedIn 进行这个交流在这块。如果大家现在有什么问题，在开始之前可以先在这里面提，也可以，我不知道你们可以unmute 自己吗？不能的话就通过那个 question 那点直接 type 进来，我这边是可以看到的，好吧？咱们再等几分钟，等大家都加进来，有问题可以现在通过那个 question 那边写出来。刚才有人举手，我把你也 mute 了，你是不是可以说话？等会儿啊，我让有人问问题，能不能介绍一下操作面板怎么用？不知那个绿色的按钮是干嘛的？稍等，韩笑，你给解释一下吗？
我们这边用户的界面就是只是保证question 这边大家可以提问题就可以了，然后呢会通过这个问题栏跟咱们的导师沟通，然后导师会看到问题后会给大家回答的。
是按了绿色的键就是举手吗？在客户端。
大家不用按绿色键或者其他的键，就只用在这个问题栏提问就可以了，这个导师会能看到大家的问题的。
好的，好的。大家还是可以直接通过这个 question 这个栏就可以提中问题，然后 咱们再稍等几分钟，可以开始这个过程。好，那我们现在就 dive in 到这个 presentation 里面吧，这样的话大家也等了一阵。Okay, so like I said, my name is Derek Wang, and I'm the founder and CEO of Taste Analytics. Essentially, what we are going to talk about today is how the concept of big data, but rather than not the concept of big data, but rather than how you could extract actionable knowledge outside from the big data by using visual analytics that combines both the human and the computational powers together. And essentially, that's what Taste Analytics is right now offering to the clients of ours, and how we see there's going to be a big trend in this sense about how data analytics is going to impact the users, kind of the enterprise users' ability of utilizing the data and making decisions out of it. So I might need to be in and out from the presentation because as people still sending WeChat over my phone, but I'll try to keep everything fluent and making sure that we got everybody's ideas here. Again, feel free to ask questions through the question session so that we can better communicate this. I know I'll try to keep this as less technical, but more of a general consumption of big data visual analysis. So, okay, without further ado, let us dive into this concept. So, essentially, big data has been talked about all over the world. I mean, here and outside US, but also in China, it's been a big wave of discussions. But essentially, what is big data? I've been searching for this concept for many years in both my research as well as in my practice about this area of analytics. The best terms I've come across is this, right? It's from Dan Ariely talking about big data is like teenage sex. So which is very true. Everybody talks about it. Nobody really knows how to do it. So that means this is a concept that has been out there for many, many years. Enterprise and all the folks are talking about it. Even my grandma talks about it. But everybody else thinks everyone else is doing it. So everyone claims they're doing it just for the sake of saving face. So this captures so vivid about big data. It is a concept that has been out there for so many years, like 20, 30 years, way back into the early stage of the computing infrastructure, that a lot of people are talking about big data as the data that actually connected to everyday's user behaviors and all the information that come out of the society. However, still up to this point, as we work with so many clients, that they are thinking about big data is still very on the surface. Their way of looking at big data is to kind of secure their shareholders' opinion about saying, are you guys actually using big data to do something? So what is really a big data problem, right? Does it matter? So for us, when we look at the big data problem and when we're consulting to our enterprise client, it's really, this is the thing I tell them. Guys, forget about the term, forget about all the buzz around central data, or forget about all this good attributes that big data can provide to you. Just focus on analytics. Data itself is a good asset, but itself is not everything. You need to have analytics, and you just need to keep calm and just do it. Just produce analytic, generating hypotheses, finding different areas that you can test your hypothesis and associate your domain knowledge within your analytical domain and actually make tangible return on investment for your organization. So that's actually one key when a lot of people looking for jobs, they don't realize, is that whenever you enter an enterprise, your sole goal is to make the engine runs faster and better and generate more revenues out of that enterprise. And analytics and big data analytics in that sense is the very important aspect and a very important kind of tool to use at this stage. And a lot of the time, big data analytics is confluent with the term of BI, business intelligence. So in my mind, what is a business intelligence is actually twofold. A business intelligence, the good way of accomplish that is actually subjective analysis plus objective facts, right? So this is a world that, although I coming from a background in computer science, doctorate in this area, I don't believe that computer is going to replace the human process, especially in the analytical world. We still need objective facts that has been collected and presented by the computing powers. But most importantly, all those are information that they need to be able to help human to make subjective analysis and kind of facilitate the humans and augment the humans to do a better analytical effort. So essentially, this is what our perspective of big data analytics is: art plus science. This is the art, which is the human analysis that is truly augmented by science, which is computational model. This suggests a very integral communication between the human association and the computational models that we generate all over the area. Either it could be a Bayesian network, neural network, or simple scalable machine learning. But all that need to be accommodated and coupled up with the human analysis capability, human reasoning, human decision-making process. Without either one of those, big data is just a limping, disabled vehicle that won't go too far in terms of impacting enterprise return on investment. So you guys must think, okay, do you have any proof? Right? Here's the proof that, like I said, we're not just experiencing big data in the past 5 years. We're actually experiencing big data way before that this term has been buzzed up in the areas, right? So essentially what we're looking at here is that the big data analytics for the general sense is back in 97, that is, there is a experiment that people put in the chess grandmaster versus the Deep Blue, which is the supercomputer back then that is playing the best of chess. So they put Kasparov versus Deep Blue, and then 3 out of 5 times, Kasparov lost to the Big Blue in that tournament. So people started financing about saying, oh, okay, yeah, computer is going to beat the human in this process. The chess master won't even do the job any good better than the computer can does it. And Kasparov actually openly admitted that, hey, as for how many moves I had a grandmaster sees, just won the best one, but the computers can see so many, and they can use brute force approach to kind of address that problem and moving kind of one step ahead of the human process. So back then, people are saying, okay, this is the end of human intelligence in terms of kind of versus the artificial intelligence. However, they repeated this process back in 2005, where a new set of computing infrastructure started populating from IBM, their Hydra system, their chess-playing computer. This time, when the championship was set up, people become more creative. They were saying this is actually Hydra versus Cyborgs. So Cyborgs is essentially a human paired with certain computational model, and then to see what are the different things against each other. So in this setting, that for the first round is they pair one grandmaster with one chess program, which is computing driven, versus Hydra, which is a super deep blue that has been way better and way computationally powerful than the deep blue back in 97. So 4 out of 5 times that actually they turned out surprisingly, grandmaster with one chess program actually beats Hydra, that the supercomputer plays chess. So people start drawing conclusions about saying, okay, that with the augmented intelligence that coming from human decision makers can actually be the pure computing artificial intelligence that generating making sense of what's going on and how they can make better decision effort going forward. However, they did something more interesting. They put amateur chess players with 3 different chess programs versus one grandmaster that with one chess program, the same setting that beat Hydra. In this sense, 3 out of the 5 times, amateurs with 3 chess programs actually won the grandmaster with one chess program. So that started making people think, what's going on here, right? So this is essentially the gist of what I was saying, the art plus science, is that with multiple computational models, that in this case is the chess program, it's a different chess program that coming in provided to the clients. They can actually generate more augmented, optimized decision-making effort than just a single computing environment or just one grandmaster with one chess program. So using this case, really that ties back into the art plus science for big data analytics and what is the most optimal way of doing business intelligence in terms of those areas that requires the business sense and human interference moving forward. And that's a lot of enterprises facing right now, and that's a lot of enterprise kind of job interviews and decision makings are looking for in the job market. So let's about big data. Let's actually not talk about big data, but more so to talk about why you should care about big data, ranging from the top level decision makers to the kind of fresh out of the school, college students, and so on and so forth. So why should you look at big data? As we're looking at the value of the question, is that big data really, if you utilize it well, it can influence politics, like when Obama in 2008 was using the big data to actually understand what are the voters' distributions, their demographics, and better secure his presidency. We can use big data to do humanitarian efforts that actually tells everybody that how suppressed voice can be reviewed and heard by people all around the world. That's the one fundamental benefits coming from the social media that has been produced out there. And we can use big data to really kind of innovate new products and services in the energy and health sector. You start hearing this health 2.0 and a lot of the effort from our clients looking at energy innovation and energy security and precautionary analysis of anything that around the energy sectors using the big data points, sensory information. Now, big data is also going to be produce a tremendous amount of value in terms of how people can help improve the education and looking at better or more customized education for different kids, and then bring the society to a degree of higher educated people and performing better performance in contributing to the society. And one last thing is big data is always tapped around the economics, right? So people using this flash boys of using big data to start stock trading or using big data to reduce the human error with the automation in this stock trading performance. But all this are just aspects, different small aspect of a big data value. What people are actually doing here, well, at least what we are doing here in Taste, is kind of using big data to reverse engineering the power law distribution, trying to using all the data that floating outside in the society and understand and depict the correlation. Note here is the correlation, not the causality of social behavior using statistical methods. Finding out causality is difficult, but then using multiple correlations is for humans to start drawing conclusions about finding out whether there are causalities or not. But all we're doing in the big data right now, as I call it, the human-generated big data era, where people texting and tweeting and imaging all this time, is really to understand the social behavior and finding out the power law distribution that has been intrinsically within this data set. So how would that benefit us, right? Understanding this period is going to help people to understand and respond to social phenomena. For example, using the data that we have been looking at left and right, and there's a big movement utilizing the social media data. That's the Occupy Wall Street movement back in 2011. We were able to help decision makers to understand, is Occupy Wall Street movement an organized event? How is the OSW movement geographically distributed? That's actually very key to preventative measures. And who are the key players in this movement? A lot of those people are hiding the hindsight. And what are the major events because there's so many events that happen simultaneously, how can we identify the major leads? And if so, what is the proper public policy from controlling this movement? And what is the right way of kind of supporting and directing this peaceful movement events? So this is what we provide using our big data analytic platforms. We provide decision makers to the ability to answer 3 questions: how they should monitor and analyze the movement, how they should respond and influence the movement, and how this could help them to validate and be proactive for such movement. So to give you a concrete understanding about what I say here is that we actually build and look at all the social media data that we can get our hands about during that period in a streaming sense, and understand what are the key topics and key terms and key conversations that has happened in this data set and as a longitudinal point of view. So this is what I say, a perfect integration point between human and the computing model is that underlying we have large parallel scaled cluster computation models that identify different evidence, identify different events that coming out of the social stream, but also coupling that deeply into the visual representation that for humans to depict the event, to understand it and make sense about it. So just some quick ways of how we're reading this chart. This is a chart for education purposes. This is a chart called the Sim River at the middle part of this. So what you are looking at is everything Occupy Wall Street in the past 2 years, starting from the very beginning of the Occupy Wall Street to the year 2012. Each color coding here, you can see there's a gradient of color coded here. Each color coding here indicates one conversation that our computing model actually automatically extracted. So you can see there's so many kind of conversations that has happened on this timeline that runs from left to right. So time goes from left to right, and then the horizontal line means different topic, different conversation, different topic, different discussions that has been automatically extracted. So rather quickly, if you latch on the concept about what I was saying, time runs from left to right, you can see that we could very quickly, as a human eye, to start seeing this Occupy Wall Street has been can be segmented into 3 different areas, right? Like that's actually answers the first question, how they can monitor and analyze this event. You can see there are precursors that come in to this middle section we're labeled C. You can see there are precursors that are actually before September 17th when Occupy Wall Street starts. That's actually very key indicator for our partners at Homeland Security, trying to understand who are the kind of initiator or the organizer of this event. Then you see in the middle between September 17th to December 31st, is that there are big shift of all those conversations, suggesting there are a lot of attraction now into this event, that people are very active, and we can automatically extract events like union workers supports the Occupy Wall Street. That tells people who are the key players are going to this social media event, as well as Marines Marines joined the Occupy Wall Street stating this is their second war that is out within the domestic territory. All those events are automatically extracted using computational models that we have developed. But visually display those events for human, especially for decision makers, we can immediately draw conclusions and correlations to see what are the timeline and how different things are kind of propagated through this time period. And as you can see, towards the end of 2011, December 31st, all this, because the weather shifted in DC and all around the nation, you can see the volume or the discussion of all this Occupy Wall Street related information start to shrink quite significantly. However, coming in January, you can see there's a bursty event that our system automatically detected. It's called Occupy Nigeria oil subsidy. So you can see that international events can also be kind of lumped into this Occupy Wall Street movement, which is, to our collaborators' surprise, is completely out of their monitoring system. Using our visual representation, they will be able to understand, okay, here is another key group of players that is actually outside the US but happening in Nigeria, who copied the movement, just like people copied this as in the Occupy Hong Kong movement. They borrow the same concept about having the social media movement. Our system, coupling with our human analysis, was able to pick this thing up. So this is a quick overview of how a visual analytics system can be powerful when placed into decision makers' hand, and then how can it be powerful when coupling the computational model behind it. But one thing that is very important is that how are people going to use this, right? So let's dive into this area of precursors of this Occupy Wall Street. And this is actually a true case study that one of our decision makers has been performed using our system, is that to look for precursors that is actually happen that leads into the the full blowout of Occupy Wall Street movement. So they can use this system to look at different conversations that happen in this area, they will be quickly understand who are the key players that has organized this event, which is not clear when you're just looking at all the social media data in the raw form, but rather we can provide them using statistical and machine learning algorithms to identify those key players. So you can see here that actually our people are talking about September 17th as the Occupy Wall Street event that is actually 3 weeks ahead of this event that actually occurred, suggesting this is an orchestrated event that happened in this on this Twitter sphere and social media sphere. And you can see what people are actually asking for support on training, medic, legal support, or just simply asking people to bring their sleeping tent and bag of food into this protest. So you can see that actually suggests to the decision makers, okay, not only we can know there are an event that is going forward, but also for them to be able to understand, okay, these are the people that from the U.S. Day and Rage that actually was a group that coming from the Canadian border that is actually hosting and promoting Occupy Wall Street, that essentially leading to this big bursty event that happened. So using this system, we actually provide them in the real-time process point of view to understand what's going on and how are things propagating in terms of in the big data area outside the traditional way they're collecting information. Now, again, I don't want to limit your mind about saying big data is just Twitter or big data is just social media. Look inside. That's what we do for enterprise. Look inside. Big data is actually everywhere inside the business organization, which I will talk about in the following slides. So with that example and that idea of big data analytics is R plus science, it's really a portal for us to know what we know and to discover the gaps in our knowledge that can serve us a better kind of way to understand what this big data, how can we utilize big data to generate something that is truly valuable and useful for our organization. It is a more effective way for us to use a diverse collection of assets that are coming out of the enterprise area. It provides better marketing coverage to limit surprise when you start a campaign or when you start a product launch and so on and so forth. This enhances the analyst's view of understanding and improve their analysis to generate better revenues for the organization. So big data, right? Now we're kind of pointing your idea into the big data analytics. It really leads to the analyst to be able to generate actionable knowledge out of the big data. However, what is the reality of the big data in our usage, right? Like I said, so many people are talking about it. Not many people are actually start using it in the proper way. So like I said, big data is no longer new. We're in 2014, right? The data concept has been out there back in the 79 from the first book of The Empires at Risk, that there's over 20 years. The term has been buzzed off in the past 5 years. That lead to a lot of people start building something that we're passing the education market. Education, I mean corporate education. So there are more companies are building comprehensive and long-term data lake that actually just sucks in all the data points. There is a realization for those folks thinking about the important data coming from anywhere, both from the internal data set of theirs, chat, emails, and so on and so forth, as well as external data set that are actually coming from the social media. There is a growing push. That's why you can see a lot of job opening in the market to find out making decisions data-driven. But this is really hampered by not knowing what actionable information the data contains. So people come into big data analytics blind of saying, okay, I'll see whatever hypothesis comes out of a data-driven model. I'm air quoting here. But really, that if you don't know what the characteristic of the data, any statistical analysis can be deceiving. It can lead you to a different conclusion or a different hypothesis that every organization need to be aware of and really adjust their approach of just purely rely on simple data-driven method. However, with all that said, big data is great. Data analytic, data-derived knowledge is great. That provides different organization competitive advantage so that you can be one step ahead of your competitors so that you can use knowledge more effectively, that you can generate more return on investment on your analytical approach. So that comes from the actionable knowledge that each decision makers make. And that will lead to profitability of the organization, which is really one key thing. Every interviewer, as we will know, as my students experienced before, is actually looking down. If I hire you, what you going to bring to the team, right? But let's retract. Profitability for the company is way beyond our head. Actionable knowledge only happens on our process. Let's dive back into the data itself. Let's dive back into the big data. The important part of the big data is data. It may be big or small. As long as data is actionable, as long as data reveals insight, those are valuable data for you. If data is just dumb and sit there, those are dumb data you don't want to deal with. So the challenge here is that how can we make sense of the data part, right? This is from Tig McCracken. That it's a comic. I think this is a really good way of kind of suggesting what's going on here. Is that a lot of guys are looking for 500 zillion data sets that is trying to make sense about it. And however, within all that 500 zillion databases, there's only the useful information of those 5K information. The question is not just finding the 5K, it's really multiple fold, right? It's which 5K? There's just so many 5Ks within here. How many are 5Ks out there? How can I connect it all different 5Ks of the data to make sense? And using those 5Ks to make decision. Who is the business owner in your enterprise? Because your all enterprise are quite departmentalized, so that you need to know and understand who are the business owners. And how should the decision maker use the 5K, right? If you see the hypothesis, how are you going to act on it? So that reflects the true challenge in this area is people don't know the future value of the data. People also cannot connect dots if they don't have it, because if they just see all those isolated 5Ks, it's hard for people to act upon it. and cannot handle the dynamicity of the evolving data streams. Like what I just showed in the social media analysis, there's no static point of social media analysis. You need to embrace that the continuous river-like data stream that you need to be able to find out different elements, different events on the dynamic process. And that means this is a huge amount of data flow. This is a huge amount of monitoring event analysis that we need to come up with a clever way to understand and moving forward on it. But how? It's easier said than done, right? So in my point of view, the how is not the raw data, right? If you just think about the raw data, it's out of the place. Data itself cannot give us anything except occupying the 0 and 1s in our hard drives and server farms. So we already entered the era of data physicality and data sociality, right? So there are locational data, temporal structures, discussion, conversation topics, and social networks, and other networks that within the organization. Those are what I call a combination of the data physicality and data sociality. So that characterizes the data both in unstructured form and semi-structured. It's really hard to find any structured data, which I mean is very cleaned, tabular forms of the data. Those data are just so skewed based on the people who are cleaning it that may not present useful, actionable information that come in within there. So when you look at this unstructured and semi-structured data, they can be very highly heterogeneous. It requires highly heterogeneous statistical models. So data capture different aspects of what's outside there on the society that has multiple facets within the data itself. So those data is incomplete or withholds, thus intrinsically contains uncertainty that, as what I said earlier, is that will, if you apply statistical blindly on those data set, it will lead you to consume some deceptions that come out of the data, which will not benefit your business, but more so harm your business or harm your job performance inside the enterprise. So what do I mean by unstructured data, right? So the challenge on the data side is the sheer size, is all these V's that people attach to the big data. But let me just capture that from the comical point of seeing. So this is actually when we talk with our friend at DHS, they shared this and say, hey, in the future, the bankers are not going to compare the asset numbers under management, but to compare the sheer size of the data that they contained in their bank. This suggests to people that there's a lot of those data that inside this bank is going to be unstructured. That's the leading directions that we're looking at here. So 95 to 99% of all data is going to be unstructured. That includes all your tweets, all your Facebook, all your WeChats, and that more importantly contains the images that you post on Instagram, anywhere you post on Snapchat, and so on and so forth. Video data set is tremendous amount of unstructured information within there. But also something that is very useful as a coming trend that we're seeing here are the sensors and the Internet of Everything that is going forward, full bloom kind of into the market. All the sensors on the vehicles, all the sensors on the Internet, or the sensors in the manufacturing world. So all this data are very largely unstructured, and some of them are semi-structured with the meta information here. The amount of this information is growing exponentially, right? So as you look at the scale of this data, 5 billion posts on Facebook, that was back in 2011 data, 30 billions of tweets a month from Twitter, and 235 terabytes of stored data set for one market sector into Library of Congress. And if you think about the 15 major areas of business in the US, that's 15 times 235 terabytes of data. And people predict in the 2019, there's going to be 1.9 zettabytes of data that is actually floating around. I mean, for non-computer gigs or not computing area of the folks on the line, those numbers doesn't make sense. But really what it means is that if you think about a DVD or a CD that 10 years ago we're still using it, right? If you stack all those CDs together, that 1.9 zettabytes of data is, I'm talking about 4.4 gigabytes of DVDs that they can store data. So 1.9 zettabytes of data can have us coming from the surface of the Earth to the moon and come back with all those DVDs stacked up together. That's how much you can visually understand what's going on about this data range. And that's not just the case, right? The scale of the size, the sheer size is just one aspect of it. But more concerning to us, as we're trying to address right now from both data science and visual analytics as a corporation, is the speed where we have this data explosion that has happened in this process. The speed has been gaining tremendously in the past 4 or 5 years, and the steep of this curve is going to be even more steep than it's going to slow down. So we're going to face another area of data explosion on the market and on enterprise. So on the data side, data analytics, big data analytics, the useful side is the analytics, which is coming from the end user. How are we going to provide end user of this analytic solutions and how they can benefit from this? But the how is not just in analytics, right? So many of you may be data science in this job market. You can see a lot of the time of data scientists, business owners, or decision makers, they spend so much time in data wrangling, cleaning up the data, trying to understand about this, but deviated from the main task, which are the tasks at hand, which they should be focusing on their decision-making effort and their decision-making assets that is outside in their organization. Their return on investment comes only from asking the right questions and act upon the exact actionable insight. However, all these analytical tools outside there are just very hard to use and very complex and bulky, and more importantly, out of context for the people to actually making sense of. So this is another challenge that in the analytic area, that tools like SAS, tools like SAP, the ones that you need a degree for, is really probably not going to help you when you move into an enterprise level of the performing useful analytics. Organizational analytics need to be more business-driven with robust predictive intelligence rather than this arcane scenarios that we're looking at the current market and job market and educational system. So, in summary, what the challenge are in the analytical area is the tools are hard to use. You need specialists to derive value rather than asking business school folks to actually derive value themselves by understanding how to use those tools. Skilled workforce right now is in short supply, so that's why there's a lot of push, even in my professorship career, that we're promoting students to be data scientists. That can be there's a huge market for those skilled workforce. There's a lack of human intelligence, so we cannot use the analytics that is purely based on the computational model. We want people actually to be injecting their own knowledge and injecting their own process and going forward. But deviate from the algorithms, which are rigid, dense, and arcane, right? You want to have something that is really within the context of your analytical efforts. But doing that requires a lot of hand curation and built for only specific tasks, not cross-cutting business. So you need to have a generalizable way of looking at analytics and placing the analytics into the human's hand and making the best out of the data and making the best decisions out of the analytic platform. So how should we do that? The how really relies on the human-centered transformation from data to actionable insights. What do I mean by this? Data plus analytics really doesn't equal to actionable insights that people are using or people are referring to in the organization. You need to inject that one level of domain knowledge in this process that coming out of from the human side to generate that actionable insight. So the solutions that we're providing is visual analytics that help people to look at both the data itself, both the analytics, but they be able to inject their human knowledge. We're promoting analytical reasoning facilitated by visual interaction interface. This is really a balanced interface between the offline data analytics and the online interactive analysis process, which means how people are using the data and how people are perceiving those analytical results. It is a collaboration between human and computers to make sense of social and natural phenomena. So it's an kind of disciplinary approach that we're providing to different organizations and future job markets as we're training data science and business analytics in my college right now to perform this area of expertise and skilled workforce. So that's what we are providing from our company point of view is every data analytics in your framework of reference, I mean the business framework of reference, is that promoting widget analytics. Widget analytics means tools in context to your own business, schema on demand, data in the context to your own task. We don't want you to be prematurely exposed to all the data. And this is truly a user-centered analytics, answers in the context of your questions, and truly to build a invisible computing. So shield it off from your own, shield the computing process off from your analytic process and let you focus on the tasks that you need to be looking at, not whether you're using Hadoop or you're using whatever data solutions out there. Because your point of view is to making decisions on top of the analytics, and that will impact your business. So a couple of solutions that I'm going to share for today, which given the time that we're having, I'm going to compress that in the next 10 minutes. And just to give you a taste of what's going on in the industries that who are looking at the visual analytics. So this is a visual analytics of the structured data set. This is one of the case where we have helped the Department of Transportation to understand how they should better analyze their bridge infrastructure, I mean, our bridge infrastructure in the States, and to see the dynamicity of how bridges are changed over the course of period and how they should balance their kind of budgetary requirements versus the actual factual information of the bridge. So one key element here, just to give you some background, is that it's like everywhere in the world, this is a budget game that on the one hand, you have 10,000 bridges that you need to repair, but on the other hand, you have very limited resource, I mean, the human resource and the budget that's been given to you. That's the art and the science part is that we use data-driven modeling to suggest to the decision maker who are the bridge inspectors and the bridge managers to actually tell them within their own budgetary and their own jurisdiction which bridge they should maintain and which bridge they should be repair in this sense. So we have provide a platform and a web-based system so that bridge managers can go on and understand all those near 700,000 bridges around the whole state and monitoring those on their fingertips. So this is the web-based interface for bridge managers. And this is the other elements about what we're doing is for financial institutes and looking at their data points to understand different demographic, different user behaviors, just purely from the streamlined transactional data that they have provided to us from their POS machines and so on and so forth. So this is to give them a quick way to look at tens of millions of data points in the real time and understand the market and understand different market sector behaviors and start providing a more robust and intelligent investment from those banks. So this is a platform that we have delivered to one of the financial institutes that our company has been worked with. So on the unstructured side, as you can see here, is that the data on the unstructured side has just been growing so tremendously in the past 10 years that this is actually a lot of effort that we have been providing as a company to our enterprise clients. I'm going to skip the emergency responder, but dive into some of the unstructured data analysis that we have been producing in the area. So the main point here is how we could structure the unstructured by looking at the data itself and asking the data to give us information and people to kind of act upon it. So we build everything around this concept of an event, where event is a meaningful occurrence in the space and time that has a lead conversation streams going to the event, and you can see what are the motivating events that has happened here, and then their duration and their volume that associate with that event. So the narrative essentially become more relevant in here is that you could start building storage around those events and identify all those like the Occupy Wall Street related stories that come out of all these events that automatically extracted from this area. So an event can be summarized based on its investigative elements, which we're kind of emphasizing are the 4W, who did what and when and where, and essentially using that and visually present all those information to the decision makers so that they will be able to know how they should explore and understand those areas of business. For example, this is one of the automatic posters that we generated in looking at different kind of political events. You can see who, where, when, what. All those informations are automatically extracted from the data points, but visually represented for decision makers to actually making sense of and act upon it. So event, in our sense, to dealing with the unstructured data, is truly to extract the topic, the conversation, the time, the people, and the location, and visually finding a most meaningful way to build those systems for people to understand what's going on out there. So give you an example. This is what we have helped with one of the health institutes that we work with to monitor and understand the disease behavior on the market, not on the market, outside and in the society. So essentially what we can help them to do is on a streaming process, we will be able to see that within this city that on day one, this is not Walking Dead, so don't worry about it. But on day one, you start seeing a lot of people talking about, hey, we have terrible headaches, and reporting all this on social media. This is especially Twitter. That's where we got this information from. And then they start reporting their movement sucks. But more importantly is that from this, as you can see in the center, from the center geographical distribution there, you can see there are a huge number of people reporting the symptoms in the downtown center area. That's suggesting those symptoms start bubbling up in that very condensed geographical region. And overnight, you can start seeing people going back to the west where they have a residential area over there, and you start seeing a lot of small kind of hotspots start showing up in the residential area with more severe symptoms start showing up where people start talking about coughing and start talking about their movement sucks again, and then their pneumonia kind of related issues started bubbling up in day two that goes into suburban neighborhoods. And on day three, you start seeing, okay, very strong key terms start showing up in this area. People talking about killing, people talking about this thing is really killing me, my stomach aches, I'm shortness of breath. And those actually indicate to the human, kind of the decision makers on the back end of saying, oh, okay, there are actually epidemic related symptoms start showing up around this geographical region. And judging by the physical hotspots, as you can see on the screen for many areas, people actually, those are urgent care areas. So people actually are going to those areas to seek for attention and kind of medicine, Medicare. However, the sad part of this is that they're still tweeting in those areas as they were going to. But this actually shows you how using our event modeling and event analysis on a large scale point of view is going to be very impactful for healthcare, very impactful for different governmental areas by looking at the kind of just the social media data. But think about all those data that people generate inside the organization, inside the governments that are centered around this area of discussion. So I think I'm going to schedule kind of skip many of these slides, but just to go into some final thoughts in here and then I'll open up the floor for discussions about this webinar, and you can ask any question you want. So essentially, this is the forte for the next generation analytic area. It's really to integrate interactive visualization and automated data analysis to derive actionable knowledge. This will help people to attack large but also very complex textual data and structured data and semi-structured data in very complex applications. In here, what we're really, for the new generation of data science or any business analysis, our analysts are going to be able to support their exploratory and their discovery effort of the data analysis effort. This truly, we're leading into the area of helping to support their reasoning and their decision-making effort using this augmented intelligence system that we believe that the job seekers will find a better kind of discussion point with their interviewers, as well as the organization can benefit from people knowing what's the next step of the organization optimization and risk management in this sense. So really here is just to kind of give you a very quick overview of what has happened in the data science area on a very high level, without boring you with the technical details, but to give you a sense about what this market will be going towards into, and maybe we can open the floor and help you to kind of see how you should prepare yourself for this area of analytics. So thanks. And the floor is open, I guess.如果有问题，大家就在 question 栏里面写一下吧。 稍等啊，有一个问题。这个问题是说，如果说做 data scientist 只做 implementation 而不去接触客户的话，是不是对长远 career 不是很好？我觉得是这样，这个东西是两个方向来看。如果你是首先，如果你能够知道客户的话，会对你的工作更方便去做。在这个过程中，你可以要求你的不是要求啊，你可以现在跟你老板建议，授一下你的 initiative， 去跟他说，如果今后见客户，你可以去旁听一下呢，就是说相当于你需要知道客户需要什么样的这个要求，通过他们的需要要求，你可以更好的实现 model 嘛。我觉得老板都会很高兴让你去参加这种活动的。我的个人建议是说，你要尽量自己给自己创造这样的机会，去多跟客户接触，然后这样去理解到底这个客户在外面是都有什么样的需求。如果只是一味的写代码的话，有可能会让这个对你的这个 career 发展不是特别的有利。不知道这样回答到你的问题了没有？如果大家都没有什么问题了，可以两个就是可以线下联系我，或者说这个通过这个 office hours 啊这种，这是一个很好的活动，大家都可以通过这个再多交流嘛。然后如果都没有问题了，那我就差不多这个 webinar 咱们今天就做到这里了吧。再给15秒，如果都没事，那我就挂了。